Okay, today we're going to talk about how we graph exponential functions. This covers the fourth geometry standard in the integrated algebra curriculum, and we've already covered most of everything. We've already covered everything else. We've graphed linear, quadratic, and absolute value functions, and now we're going to talk about exponential functions. Our vocabulary today is exponential growth and exponential decay. So let's look at our first exponential function, that is y equals 2 to the x. Now notice we are used to looking at things that look like this, y equals 2 times x, okay, where the x is in, the 2 is being multiplied by the x. But here, we are also used to looking at something like y equals x squared, where x is the base of the power, and 2 is the what x is being raised to. The one that we're looking at today is sort of the first time that we've seen the variable in the exponent position. So what we're holding constant here is we're holding the constant of 2 as the base, and we are raising 2 to higher and higher powers, or lower and lower powers. So let's choose some values for x that would be helpful here. So I'm going to start with I'm going to start with 4, and I'm going to go down. So 4, 3, 2, 1, 0, negative 1, negative 2, and negative 3. It's always good to choose values that are both in positive, negative, and the value of 0, just to see how this function behaves at those values of x. So for 4, I'm looking at 2 to the 4th. Okay. Now 2 to the 4th is, so that's 2 times 2 times 2 times 2. Okay, so that's 16. Okay, so our xy value would be it would be 416. Okay, and 2 to the 3rd would be 8. Okay, so it would be 3, 8. 2 squared would be 4. So that is 2, 4. 2 to the first power is just 2. So we have 1, 2. Okay, 2 to the 0 power. Now, if you recall, anything to the 0 power is going to be 1, with one exception. 0 to the 0 power is not defined. Okay, that's not defined. That's something that it's sort of the intersection of two rules. It's the intersection of the rule that 0 to any power is 0, and a to the 0 power is 1. So what's that going to be? That's a question for that. So anything to the 0 power except 0 would be 1. So 2 to the 0 is 1. So here we have 0, 1. Now 2 to the negative first power. If you recall, 2 to the negative first power is 1 over 2 squared. So it's 1 over 4. So we have 1 fourth. So we get negative 1 and 1 fourth. 2 to the negative 2 is going to be it's going to be 1 over 2 squared. Whoops, and I made a mistake over here. Let's do this again. 2 to the negative first power is going to be 1 over 2 to the first power, which is 1/2. So this should have been 1/2 here. So this is 1/2, and then it's negative 1 and 1/2 here. 2 to the negative 2 power is 1 over 2 squared, so that's 1 fourth. And this will be negative 2, 1 fourth. And finally, 2 to the negative third power is 1 over 8, because it's 1 over 2 to the third power. So we have negative 3 and 1 over 8. Okay, so if we plot these, so I'm not going to plot the first point, but the second point I can plot. So we have 1, 2, 3 here, and we have, it's kind of hard to see my my lines, but let's see, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8 right there, and then 2, 4 would be 2, okay, and then 1, 2 be here, and 0, 1, so 0 on the x-axis, 1 on the y-axis, and then negative 1/2, so it starts to become very close to the y-axis, the x-axis rather, negative 2 1/4, negative 3, and so it's a little hard to see here. So if you connect these lines, what's going to happen is it looks like this curve right here. Okay, and this is the curve y is equal to 2 to the x. Now, what happens on the left-hand side here is it gets really, really close to the x-axis, but it actually never touches the x-axis, and it never crosses the x-axis. So it gets really close down here, but it never touches. So make a note of that. Never touches x-axis. So of course, since it never touches, it never crosses. Just gets closer and closer to the x-axis. If we were able to zoom in, we would see that. So this is our first example of an exponential function. Exponential meaning that the variable is in the exponent position. So these type of functions grow faster than any of the functions that we've seen before. A quadratic function is going to grow, it's not going to grow as fast. Exponential functions grow, so by already x is 4, it's already 16. If x was 5, it would be 32. If we filled in some more of these things. At x is 6, whoops. If x is 6, y would be 64, right? 7, y would be 128. 8, y would be 256. So already at x is equal to 8, it's already at 256. So it goes really, really fast. It sort of just shoots right up after it. After the first few positive values for x, it shoots right up. The other thing that you should notice is that it crosses the y-intercept is equal to 0, and that's going to be very common with our exponential functions. That's because when we look at this value right here of the value of y when x is 0, this is 1, okay, and that's because of the property of a 0 exponent. Anything raised to the 0 power, so let's recall that property, anything raised to the 0 power is going to be 1 with the acceptance of 0. Okay, so let's investigate another exponential function. In this case, what I'm going to do is I've made the base, so we have y is equal to 1/4, and I'm going to take the base, which is a fraction, and I'm going to raise that to different quantities of x here. Okay, so I have the 1/4, and I'm going to choose some values for x. So let's choose 3, 2, 1, 0, 1, 2, and 3. Oh, sorry, this is -1, -2, and -3. Okay, and we're going to see what happens here. So first of all, let's look at 1/4 to the 3rd power. Well, that's 1/4 times 1/4 times 1/4. Okay, so clearly the numerator is going to be 1. Now 4 to the 3rd power is going to be 4 squared times 4. Well, 4 squared is 16. Let's multiply that by 4 here. It's going to be 64, so it's 1/64. So pretty tiny here. So this is going to be 1/64, and our coordinate is going to be 3, 1/64. Okay, so 1/4 squared is going to be 1/4 times 1/4, which is 1/16, so we have 2 1/16. 1/4 to the 1st power is just 1/4, so we have 1/4 here, and we have 1 and 1/4. Then 1/4 to the 0 power is going to be 1. Okay, so 0, 1. So we see that number again that we had in the last exponential function. Now, something strange happens when you raise 1/4 to a negative exponent. It's not really strange, and you've seen it before, but let's just recall here. So if I have 1/4 and I raised it to the -1, what I can do is reciprocate the base, so that would become 4/1, and raise that to the 4th power. Okay, well, 4/1 is just 4. If you raise that to the 1st power, that's just 4 again. So that's going to be 4. So -1, 4, right there. Okay, let's try it with -2 here. So -1/4 to the -2 would be, again, we reciprocate the base and raise it to the positive exponent. Okay, well, 4/1 again is 4. 4 squared is 16. So we have the value of 16 here. -2, 16. And if you look at what's sort of going on here, 2, the value, when x is 2, y is 1/16, and when x is -2, y is 16. So it's just sort of taking the reciprocal. So you could calculate it again for -3, but you're going to see that it's the reciprocal of +3. So positive 3 had 1 over 64. Negative 3 is just going to have 64. So we have negative 3 and 64. So when we start to graph this, 3, it's 1 over 64. This is really, really small. So at the x value of 3, it's going to be super, super close to the x-axis. I don't even think I can get that close, but let's just sort of make a mark here to indicate. And at 2, it's going to be 1/16, so it's a little bit less close. At 1, it's going to be 1/4, so it's like a little hard for me to estimate, and all these dots are almost kind of in the same position, but we'll try. And at 0, it's going to be 1 again. And at negative 1, it's going to be 4. And at negative 2, it's going to be 16, which is actually already off my chart. So negative 2 would be somewhere up here. So I'm just going to sort of connect the dots here and start looking at this. So this is the graph of y equals 1/4 x. Now what's happening here, let's look at how this compares to the other graph. The other graph sort of starts to, as it gets into quadrant 1, it begins to rise very fast. But the graph that we just did, it does this, it's sort of the same graph except it's reflected, both pieces are reflected across the y-axis. So this was the original graph. Okay, that was our y is equal to 2x. And in fact, it actually wouldn't go up. Let's see. It actually would look something like, it's not going to go up as fast. So that would be something y equals 2x. Now, it looks like both portions, like this portion right here, if you flipped it over the y-axis, it would become that lower portion. This branch right here, if you flipped it over the y-axis, it would become the other portion right there. So this leads us to our two types of exponential functions. The exponential function with a base of a positive integer, and the exponential function with a base of a proper fraction. So this is going to be our exponential growth. So our exponential growth looks like this. It looks like y is equal to some value of a to the x, where a is greater than 1. Okay, and that's going to look like, so let's put this in red, that's going to look something like this, where it will grow up like that. And actually, this portion right here is not correct. Let's try this one more time here. It is going to look like, so it gets really, really close to the x-axis, it sort of rides along it, and then it shoots up like this. Remember, that point is always 0, 1. Okay, this is y to the a, y is equal to a to the x. Now our exponential decay is going to look like that too. Y is equal to some value a to the x. Actually, what we can do is we could put it as some value a over b raised to the x, where since it's a proper fraction, so where a over b is a proper fraction, okay, meaning that a is strictly less than b. And what that's going to look like is you're going to have your axes here, your x and your y axes, and you are going to see it, and instead of, so it's going to sort of ride along the x-axis for a while, and then it's going to pop over to quadrant 2 here. And remember, this point again is 0, 1. So this isn't the best drawing because it actually doesn't go up, and it just continues getting closer and closer to the x-axis until it, the further x out, the higher the x value is, it's going to get closer and closer to the x-axis. So these are our two models here. So this is exponential growth and exponential decay. We're going to investigate this more in class tomorrow, but you need to have this in your notes for tomorrow. Okay? And this is our final type of graph that we are going to go over in integrated algebra. We went over the linear function, the quadratic function, we went over the absolute value function yesterday, and now we have exponential functions.